Uh, okay, so something that I forgot to mention last time or send out an announcement about is the fact that the video for the last lecture, the workshop we did, is on this playlist. So if you scroll down, you'll find it um, right here, right? So this is the Biophysics 421 Fall 2021 Workshop 1, right? And so you can find the entire video there. And today, as I said, we're going to be working with PyMOL. So before we actually get started with that, did everyone get a chance to install PyMOL? Anyone having issues installing PyMOL? So if you are, you can either send us a message or raise your hand or something along those lines. Okay, so everyone got PyMOL installed. Okay. Um, so one thing that you don't necessarily need it, right? But it actually makes life a little easier is that the full featured version of PyMOL requires a license. And so the University of Michigan has a site license, and I went ahead and downloaded that license. Oh, I think something in the chat. So no means what? No, you were not able to install it, or no, you're not having issues installing it. Okay. So let me show you how you can get access to this license. So I've added a module. So if you go to Canvas, right, and you click on modules, you should see this modules for the PyMOL workshop. And there's lots of things that we're probably not going to touch on today. But for example, I have a video on the importance of molecular visualization and modeling. So you can go ahead and take a look at that. There's also a video similar to what I that's in a playlist that you can use to get some guidance in downloading PyMOL. It seems as if everyone was able to do that. And so right now, let's try to get the that. Let's go ahead and get the PyMOL license. Okay, so if you click on this link, so it should take you to this page here, and you should be able to download the license. So once again, just you go to modules, then the PyMOL workshop, and then you click on this link, the PyMOL site license. Should take you to a Dropbox page that allows you to download the license. So you can go ahead and download the license. And then when you open up PyMOL, right, I think it would ask you for a license file. You can actually point it to this file, and it should be able to recognize it. And that's how you would be able to, enable the full featured version of PyMOL. Okay. So other things, I've also added a link to this files. So if you click on this, this is just a link that takes you to a Dropbox page. It includes the license as well, but also a PyMOL cheat sheet and a couple of coordinate files that we will use today at some point. So if you want to go ahead at this point and download these two coordinate files, you can go ahead and you can do that at this stage. So let's go back to modules and let's talk a little bit about coordinate files, right? Because I just used I've been referencing coordinate files, and we didn't really talk a lot about coordinate files. And so this is a page that kind of gives you a quick introduction to coordinate files, and I think it would be worth a while to kind of go through that today. The first thing is, what's a coordinate file, right? So this is just a file that stores XYZ coordinates for a molecule. So when you determine a structure by extracrystallography, for example, what you do is essentially, provided you have good enough resolution, you determine the X, Y, and Z coordinates of every atom, right? and that defines the structure. So there are many formats for coordinate files, and so you could click on these links to get a more extensive description with different kinds of formats. But the one that's most typically used today, even though it's probably going to be replaced at some point, is the PDB file format. And so what you're seeing here in this image is an example of an image taken from a PDB file, and it contains the information about the system. So what does it contain, right? So it gives us information about the element of every atom, right? So for example, atom 1 here is a nitrogen, right? Atom 2 is a carbon. Atom 4 is going to be an oxygen, and so on and so forth. Then it tells us the amino acid associated with that particular atom, right? So in this, and so you see that shown here. And then you have something called a chain ID. So you can imagine if you have a system that's made up of multiple subunits, and imagine it's a homodimer, right? To be able to distinguish one from the other, you have these chain IDs. So for the first monomer in the dimer, you can give it chain L, and the next one you could give it chain L, so you can distinguish them. Then there's a sequence number, and that's shown here. So in this example here, the sequence number is 1. So and then you have the X, Y, and Z coordinates, and some additional information that we could ignore for now. So if you think of it, for every row in this file defines the information for a particular atom, right? So in addition to the XYZ coordinates, you know the residues associated with, or the sequence number is associated with, the amino acid of that residue, and the atom type itself. So this is ultimately what's produced after extracrystallography is finished. You have this coordinate file, and it would probably be a good idea to kind of show you how you can get access to view one of these coordinate files from the RCSB. So let's go ahead and do that. One thing I just want to make sure, are you guys all seeing my my screen? Because I'm not seeing that green bar on my screen. Liz, are you seeing my screen?
Yep, I'm seeing your screen.
Okay, cool. Yeah, I'm just paranoid that it's not. Okay, so let's go to the RCSB. And again, the expectation here, if you want to maximize this workshop, is that you kind of follow along as much as possible. So if you have a web browser open up, let's go to the RCSB. And you can select any molecule you want. Here, I'm just going to choose a particular molecule. I know the PDB ID, so I'm going to put in the PDB ID 2L94 and hit enter. And so this is the structure that comes up, and that's associated with this PDB ID. Again, you have some information about the molecules. So this is the structure of the HIV-1 frame shift RNA bound to a small molecule, right? Other relevant information would be the fact that it's solved by NMR spectroscopy. And in this case, they've actually submitted 10 structures rather than a single structure, right? So it's a bundle of structures. And so if you want to view the PDB, the coordinate file, you can actually click on this Display Files button. So you can click on this, right? And you can go to PDB format. So go ahead and do that, and you should see a file that looks like this. There's a lot going on here, but I'm gonna kind of skip to the relevant parts associated with the coordinates, right? So you see we have something like this again. We have the index for the particular atom, the atom name, right, where the first character in the name tells you the element. Then you have the residue type, so it's not amino acid now, right? It's a nucleotide. So this one here is a G, so it's a guanine. Then you have the chain ID, which is A, and the sequence number here, which is 1. And then you have the atomic coordinates X, Y, and then Z, right? And some additional information, which for now we could ignore. I guess it's worth mentioning in this last column in this particular file, you have the element right? So for example, this is a this atom is an O, then a P, then an OC, so on and so forth. You would notice that in this particular case, right, I mentioned that there are 10 models that were submitted, right? So if you see model 1, and if you scroll down a little bit, you would see model 2, right? And so these coordinates have been stacked in this file. So that's just a quick and dirty introduction to the coordinate files, right? Again, you can at your leisure you can read read this page here that I've given you access to if you feel like you need to. So the take home is that from structure determination methods, what you have is a XYZ coordinates for all the atoms in your system, and what we're going to do today is talk about using PyMOL to read in these kinds of files and visualize them, right? So before I move on, any questions? None? Okay. So there's another page I have here about visualizing coordinates. And so it kind of gives you a sense of some of the major steps, right? So typically what we do is we load the coordinates, we select specific atoms we might be interested in examining. You could talk about extracting coordinates and then saving coordinates. And these are the things we're going to talk a little bit about today. And I'm going to show you exactly how we do that using PyMOL. Again, I encourage you to just read this page at your own leisure to be able to be more familiar. I've kind of littered this with a bunch of links that I think would give you additional information if you would like. So for example, PyMOL is not the only visualization tool you can use, and so I've included links here to other visualization tools, for example, VMD, Chimera, and JMOL that one can use. And then I've also included here a link to a video that demonstrates how you can do some of the basic visualization with PyMOL. But that's going to be a bit redundant because we're going to actually do that today. Okay, so I'm just going to close these files. So another thing you should do is should navigate to this link here. I'm going to copy and paste it into the chat. And so go ahead and navigate to this link, and this is a good resource. Again, contains tons of information, and it could be a bit overwhelming, but I think what's relevant for you at this stage would be tutorials. And then there is information on all the different commands you have available to you in PyMOL. I would avoid this at this point because it could be a bit overwhelming. And then there's a cheat sheet which I've actually have opened here, which you can take a look at, and I've added to the Dropbox folder. And so this is something to keep handy as you work through PyMOL, and we'll reference this a bit at the end. So something I just came across is this gallery, and so if you click on the gallery, it actually shows you some examples of PyMOL generated images. And if you scroll through these are really fantastic images. At least, for someone like myself, I find myself geeking out in these images. And so what we're actually going to do at the end is that I'll allow you to kind of choose one of these images to try to recreate in PyMOL, because the cool thing is what they've done here is to give you the exact commands you can use to be able to try to make these images, right? So we're gonna try to see if we can reproduce some of this, and we'll do it right at the very end, just as a fun thing to do. This one in particular is pretty nice. I really like the way this looks. But anyhow, so let's open up PyMOL. So for me, since I'm using a Mac, my PyMOL, I can find PyMOL in my applications. So I'm going to go to applications, and then I should have PyMOL someplace here. So I'm going to double click on PyMOL. So if you're working on Windows, will be obviously be different, but everyone go ahead and open up PyMOL and then give me thumbs up to let me know that you have it opened. So I guess one of the disadvantages of not having my video on is that I can't see the participant list. So I'm going to actually turn it on again. It seems as if almost everyone has PyMOL open up, right? And so if you don't, just speak up and or send Liz an email telling her you're having some issue. It seems as if that's not the case, but just in case. Okay, so here's PyMOL. This is what PyMOL will look like. So I'm gonna kind of maximize the screen a bit, right? And so this PyMOL window kind of has three main parts, right? So you see this upper panel, right? This is referred to as the upper control window, right? And so you get, this is where you sometimes see messages printed out, and then it contains this line here where you can actually enter in commands, right? So for example, in this gallery, in this page here where you give you some examples, these are commands that you can actually paste into this line here as you work your way through them. Then you have what's called on this side, you have the object control panel. So this is the panel to the right. And then you have the viewing window. And so when you actually look at structures, this is where the structures would show up. So the most basic command, I think, in PyMOL would be the fetch command. And so the fetch command allows you to fetch download coordinates from the PDB, right, from the RCSB. So we just a while ago went on to the RCSB and we took a look at that PDB based on the PDB ID 2L94. So we can actually go ahead and fetch that and open it and load it into PyMOL. So you type fetch and then the PDB ID 2L94. And then you hit enter and something like this should show up. And so again, just to make sure we're on the same page, quickly indicate if you were able to fetch this coordinate file and you're able to see this coordinate file. Yeah, most people seem to have been able to do this. And so like we did in the 3D viewer on the RCSB, you can rotate this molecule from left to right. You can work it up and down, right? And you can also zoom into the molecule. In my case, I'm kind of using my trackpad, and so using two fingers, and I'm pressing down with the two fingers, and I'm scrolling back and forth to zoom up, to zoom moving my two fingers up to zoom out, and when I want to zoom in, I scroll down to zoom in, right? And so, okay, so what you're seeing here is a visualization of this molecule, right? And of this particular RNA bound to this ligand. And so all that's happened here is that PyMOL has gone in, downloaded the file, and loaded into the viewer. And so some of the things you typically want to do. So we have the molecule in the viewing window, right? So let's notice that in the object control panel now, you see this 2L94, which is referencing this particular object we have here. So imagine you had multiple objects. So let's say we wanted to get access to another PDB ID, in this case 2KOC, right? If you were to add this here, you would see this object showing up on this panel as well. And then you can choose which one you want to enable or disable by just clicking on this. So to hide this 294, I just click on this object. If I wanted to enable it again, I would click on it again. If I wanted to disable all of them, I would just disable all, show all, so on and so forth. So you can kind of play around with this for a bit. So right now I'm just going to delete 2KOC because we're not going to need it much. So you can actually do this in two ways, right? So you can type delete and then the object name. Or I could have actually, imagine this was here. I could do this, click on this A here, this is called the action button. And if I scroll down somewhere, I could see delete object. And so I could delete the object here. I like using the command line here to type things out, but if you're new to PyMOL, it's sometimes very much easier to use the GUI, right? So let's explore the object control panel a little bit more, right? So remember I mentioned that for this particular entry, right, if you go back to the RCSB, remember I said there are 10 submitted structures, right? So when you look here, there is this state segmented and tells you the number of states in the object. The total number of states is 10. And the one that you're showing right now is state 1, right? And so you can actually cycle through the different states. So if you click on this button here, right, you can go from one state to the next, right? So state 2, state 3, state 4, state 5, state 6, state 7, 8, 9, 10. Again, I mentioned that I like to use the command line. You can actually do this on the command line by using the frame command. So you can actually tell it which frame you want to go to, right? So let's say I want to go to frame 5. I could just say frame and the number, right? And it'll go to frame 5. If I want to go back to frame 1, I could do that, right? If I want to go to frame 10, I just type this, okay? So if you click on this S, this gives you the sequence information. And so you can see here the sequence of this particular RNA. So the first residue is a guanine, right? And the last one is a cytosine. And so you could just see the sequence here. And if you click on any of these, right, it actually does something, right? So if you click on this one, right, you see it creates a selection object here, right? And so that's the selection object shows up. And in addition to creating a selection object, you can actually see these kind of pink or red dots showing up in the viewer. So every one that I click, this will happen, right? If I want to clear a particular selection while working with a sequence, I can just click on the selected sequence and this selection goes away. Now, I mentioned that this, you can see in the viewer that you have this ligand here. And so this ligand is actually associated with this ID, sequence ID. And if you wanted to kind of zoom, yeah?
A couple of students missed the display sequence command. Could you go back to that real quick?
Sure. Okay, so if you wanted to display the sequence, right? You see this S in the bottom here, you could click on it. So click on the S and you should see the sequence showing up. And so let me know if you were able to do that, and then I'll proceed. So Liz, you let me know if the students who were having issues are now able to display the sequence.
Yep, it looks like it was just a mix-up in hearing you. They clicked the F button, not the S
button.
Yeah,
S. Yeah, my bad. Yeah, that happens. Okay, so let me also make sure that I'm not cutting off my screen. Okay, so I was good. Yeah. So now you can select it on the ligand, right? So this particular L94 correspond to the ID for the ligand, and one of the things you can do, you see this selection object now gets populated. You can actually use the action button to zoom in on that. So if you were to zoom in, you now are able to zoom into this residue, right? So let's try it again, right? You could have any particular view, right? And so you select this particular residue, you can now zoom in on it using this zoom command. And this is not special to the ligand, right? You can do that for almost any residues. You can click on it, it gives you a selection object here in the object panel, and then you can just zoom into that residue. So let's talk a little bit more in a more systematic fashion about what you're seeing here, right? So in the control window, there's this A, S, H, and L, and C. So I kind of shown you a couple examples of this action button, right? So that's action button allows you to operate on your object in terms of some specific kind of action. This show button allows you to change your representation, so what it looks like. And so, for example, one could show this as a sphere, right? So using Van der Waals sphere. And so if you click on that, right, you should see that object now showing up as a sphere, right? So try this out yourself. Click on any particular residue, zoom in on that residue, and then change your representation to a sphere. And so again, for those of you who are following along, let us know if you were able to do this. And then Liz, just you give me a sense of how many people give thumbs up and whether or not you think I can continue. So everyone was able to execute the last step, right, which is select on a particular residue and then zoom in on that residue and change the representation to spheres. Okay, cool. So now there are other kinds of representations here, right? So you can play around with the different kinds of representations. For example, let's say we want to show sticks, right? We can do this, right? So you see all these sticks show up. Doesn't lead to a very pretty picture because we also have the cartoon representation in the back here, but it's just meant to illustrate how you can change the view. Sometimes you want to show surface, right? I showed you how to display the surface in when we were looking at a 3D viewer on the RCSB. So you can do something similar here. You can show surface, and then you should see the surface showing up. Again, these kinds of representations with a molecular surface is helpful when you want to, one, you might want to project some properties onto the surface, or two, you might want to see how a particular complex kind of fits together, right? So here you can see the ligand kind of on the surface of this particular RNA. So there's a hide button, so you could hide everything if you wanted to. So if you click that, you would hide everything. Should do it on this. So because I had this deselected, right? Let's apply the hide button to everything. So if you're on the all object, let's go click on hide and hide everything, and everything should disappear, right? And then we can go back and show everything if we wanted to. So one of the things you should notice that when I hid everything and then went and show as cartoon, right, you no longer see the ligand, right? And part of the reasons that the ligand doesn't have a cartoon representation So if we want to now show this ligand specifically, let's go ahead and select the ligand and then show as spheres, for example. So we can now show the ligand as spheres inside of the pocket. There's also a label button that allows you to label the scene. So for example, you can label the residues, you can label the chains, segments, the atom names, right? And so for example, let's label the residues, and this is what you get, right? You see all the labels, so all the residues, gives you the first character is the residue type, in our case nucleotide, and then the next characters correspond to the residues, right? So for example, C-13 corresponds to residue 13, which is a cytosine. So you could also label atoms, and you could play around with this if you want, just to get a feel for how this works. The other operation that we very often use is to color things, right? So we might want to color a particular object, and so you can click on this C here, and it gives you the color. And there are different ways to color. So you can color the entire object, right? So let's say we want to color everything red, we can go ahead and do that. Notice that the object is colored red as well as the sequences here. And this is helpful sometimes because it allows you to identify the elements based on looking at the sequence or just the molecular viewer. So for example, if I now select on my ligand again in the center here, and I say, okay, let me color that as blue, then you can see it's shown up a blue here in the molecular viewer as well as the sequence, which can be helpful at times just to orient you when you're working with a particular object. Okay, so we can load objects, right? And so a next natural thing we might want to ask is, okay, can we save objects? And you can save the object, you can save the coordinate file. And so to save a coordinate file, again, there are multiple ways to do it, and let's use the graphical user interface in this example. So if you click on File, see there are many options that you get, right? And one of them would be to save or export molecule, right? So I can export the molecule, and a number of options here, but we're just going to use the default options for now, and just say save. And I'm going to do it on my desktop because it's easy to find, and so it's just as this object called tests. And so this is saved, and I could use this for future, in the future if I needed to. Now, another thing that you might want to do is to save a session. So, since we've fetched this PDB, this PDB, and we've made some changes, right? Let's say we wanted to return to this at a later date, but we didn't want to have to repeat all of the things we just did, right? So what you can do is actually save what's called a session, right? And so you can save a session, and I'm going to go ahead and save a session on my desktop, and I'm going to call it tests. And I'm just going to leave the extension as is. So just call it test, and the extension is going to be added. And so I'm going to click save. So what I'll do is to demonstrate why this is useful, right? So let's say, you have something else to do and you close PyMOL, and then at some point you come back to this, right? So what I'll do is navigating to where I saved this session, and I'm going to double click on it. And now I have the same session saved, and I don't have to repeat everything that I just did, right? So this is just to demonstrate the utility of being able to save a session. Okay, so let me stop for a couple minutes and field any questions you might have. This is I'm moving pretty quickly, and so really want you to, if there's something that you want me to go back and just kind of like touch on again, now is a good time to do that. So let me just stop for a bit and take any questions you might have. are you all able to kind of follow along? At least those of you who are attempting to follow along, have you been able to reproduce? For example, have you been able to save this object and then reload it? It's one person. So should I revisit saving object, for example? Because I only saw one person saying that they were able to do it. So saving I should distinguish the difference between saving an object and saving a session. And so I can do that right now, right? So I'm just gonna quit PyMOL, right? So I have these two files here. This is the first one is when I saved the object, just the coordinate file. So this just contains the coordinate information, right? So if I open this up, then this is all I see, right? So which is kind of like just the raw coordinates, nothing to do with the different kinds of operations that I applied in PyMOL. Now, if I open up the session, right, then you see the same coordinates. However, it's the exact session that I had saved. So I don't have to redo, for example, the coloring, the labeling, or whatever. So let's say you're working on the paper review and you're preparing a figure where you want to kind of highlight something relevant to the paper based on the structure, and you created a scene or in PyMOL, and you wanted to then be able to save that and not have to redo it. Saving sessions really helps in that case, right? Because you can save the session, go off and do whatever you want to do, and then come back and load it up and then start from there again. Just to reiterate the way you save a session, right? So I'm just going to close this one for now, and I'm going to show this one as surface just because I want to make it obvious that these are two different sessions. So I'm going to show this as surface, and I'm going to save another session. So I can go to File, then Save Session, and then just give the session name. So I'm going to call this test 2 as the session name. And so you see that file shows up on my desktop as test 2. I'm going to close PyMOL and then reopen it just to kind of re-emphasize the point, right? So now the session is saved. Okay, so I'm going to open up this one here, and some of the things that you typically want to do is to, imagine that you created you colored the molecule the way you wanted to do. You highlighted the things you wanted to highlight. You labeled the things you wanted to label, right? And so now you might want to take a picture, right? Because you might want to include something in a presentation or a manuscript, or use it for something else. And so you want to take a picture here, right? So PyMOL comes with facilities that allow you to take an image, right? And so the one thing you can do is, there are two ways you can do it, right? One is you can click on this button here. So go ahead and load this molecule or a molecule, and then click on this draw/array button, and this window should pop up. And so this is just a way to render the image. And so by rendering, I can show you what that means, right? So I'm going to click on draw, which is the fast way. And then you should get this screen, and then it gives you two options. One is to copy it to your clipboard, right? So imagine you're working in PowerPoint. If you copy it to your clipboard, then you can paste it into PowerPoint. The other is to save it as a file. I'm going to click on Save as File, and I'm going to put this file on my desktop, say test image. And so now I have this image of my particular scene, right? So again, just to reiterate, right? You have a particular, you want to make an image. You click on draw, and then you get this window. You choose either a fast rendering or a slow rendering. Let's go with the fast one for now. You save as a file, and then you can save the image. So there's the ray option, right, that you see here, which it says slower. This is just a different way to render the image. And so let's see what happens when we use the ray rendering. You can see it allows you to, for example, get an image where you've removed the background, right? So it's no longer a black background, it's a transparent background, for example. And you could save the file the same way. So it's just a different way to rendering the scene, the image. It's a little more computationally expensive. And so if you just need a quick image, I would just go with this draw fast option here. So I mentioned there are other ways to do this drawing, right? Or taking a picture. So let's go to the file button, and you can export as image, and then you could choose a different image you want to export. Typically you want to do PNG, very portable file format, and you can click on save as PNG image, and I'll just call this test image 2. If you go to your Finder or your analogous interface on the Windows, you should see the image here, right? So again, save the image, file, in PyMOL, you go file, then export as image. You choose the image type PNG, save as, and then you give it a name, and then you save. So if you haven't, try saving an image using either one of the options that I gave you. And again, let me know if you were able to do that. So 2 thumbs up. 4. Liz, is there anything in the chat that I didn't address?
No, I think we're good as of right
Okay.
now on what you've been addressing.
Okay, cool. Okay, let's do something a little more exciting from the perspective of seeing something move in PyMOL. Okay, so let's delete everything in our in PyMOL right now. So if you go to action, I think you should be able to do it. So you click action and delete everything, right? You can delete everything, and you should be able to remove all of the objects. And so what I want you to do is to remember I mentioned that on Canvas, right? Include a link to this folder here, and I asked you to download these files, right? So I have these 2 files, SAM1 and SAM2. So I want you to go ahead and download this. Then I'm going to open up that directory, and I have these 2 coordinate files. So what you want to do, well, I should just give you a couple of seconds to get these files downloaded. And once you've got it downloaded, select these two files, right? And what you can do is just simply drag these selected files into your viewing window and just drop it, right? And so what these are coordinate files for the same RNA, just different conformations of the RNA, right? So this is the first one, and then this is the second, right? And so you can see that they're quite different, right? There are parts that are particularly different. So one thing that you very often want to kind of be able to describe is, you know, what kind of motion would allow you to go from one to the next, right? So you want to create what's called a morphing trajectory, where you morph one structure into the other, right? And so PyMOL allows you to do this. But before, let's see, there's there. Okay, how do you get to the files again? Let's make sure. So if you go to this, the modules page on Canvas, and then you go to this PyMOL workshop, you click on this files link here. So you click on this link, and it should open up this Dropbox folder. And then you could go all the way to the, on my screen, on the right upper corner, and click on download. And it should download that zipped folder. And then you navigate to wherever you have that zip folder. In my case, it's in my downloads. And you have to unzip it. On a Mac, you could just double click on it and it opens up the folder. And in that folder, you have the two files, right? Alternatively, I might be able to just send you the files in Slack. And then once you have those files, you just select them and you drag them into the PyMOL window, right? So again, just to make sure, for example, I just delete everything here, and then I can drag these two files into the window. So one of the things we can do is, let's say we want to color them different colors to make it easy to kind of distinguish the two. So let's color the first one red. So you can click on the color button and then you say choose your favorite red color. Then for the second object, we're going to color it, I don't know, cyan, and so we can choose this. So now we have these two. It's kind of easier to distinguish to make out the fact that these structures are quite different. So one of the, I think a very often used feature of PyMOL is this function that morphs between two structures, right? And so how do you do morphing? Again, two ways to do it. You can do it by typing things out here on this line, on this command line. But because, you know, a lot of you are just first time being introduced to PyMOL, we can use the graphical user interface. And so go ahead and click on the button plugin on the PyMOL menu. And you should see now plugin manager, legacy plugins, and a list of plugins. And all the way to the bottom, there's something called morphing. So go ahead and click on this morphing plugin. And what you should see is this window coming up that says conformational morphing. And so what it has is essentially an interface that allows you to control the morphing. So you can select the two objects between which you want to do the morphing. So the start coordinates, let's reference it to the object, right? So the start conformation will be SAM1. So that's this first conformation. And the end conformation is going to be SAM2, which is going to be this one here, right? The sign. And for now, you could ignore these. Very often you want to superimpose. So let's say we're going to superimpose the structures. We will talk a little bit more about that, what it means to superimpose structures in the next workshop. And so activate the superimpose button, and then just go ahead and now click morph the trajectory. I'll just click morph. It'll take a little bit of time. And depending on your machine, right? And so you can see in your control window, a bunch of messages were kind of printed out. We could ignore that for now. After the morphing is complete, right, it creates a new object, right? So this object has 30 states. And all it is now a set of states that take you from the starting confirmation to the ending confirmation. And so if you now press on this play button, provided that you've disabled all of the other objects and you just highlighted or enabled the morph one object, you press play, you can see what's happening, right? You're morphing from one confirmation to the next. And this kind of can give you, at least allows you to describe to someone the kinds of the structural differences between two states, right? Because it's clear based on this morphing trajectory that there's a significant amount of conformational changes that have to occur to take you from the two, right? And so when you include everything, you can see it takes the morph trajectory is taking you from state A for SAM1's conformation to SAM2. And if we wanted to kind of use a different color for the morph trajectory, you'll see that here, right? So this morphing is, again, very often used in research to be able to describe the differences between two conformations, but also come up with a hypothetical model for how they go from, how you might transition from one to the next. It's important to know that this is mostly a geometric technique, right? So we can't really claim that this is a physically relevant path, but it does give you a visual sense of what kind of conformation is going to be, conformational change is required to go from one to the next. So how many of you were able to create this morph trajectory? Okay, so I guess it always makes sense to do things twice just in case, right? So just to be a bit, so I'm gonna again do this. I'm gonna do it quickly this time, right? But I'm gonna do it again. And so let's say we again delete everything, and all I did here was to grab my confirmations. Which I had in here. I dropped them in here in my window, and then I just used PyMOL. I went to plugin, then I chose the morphing plugin, and then again, these are the starting confirmation object, the first object, and the confirmation the second, and then I said, okay, I'm going to superimpose, and I'll explain what that means later on. And then I just generated the morph trajectory by clicking on morph, and after several seconds, the morph trajectory shows up. So another example of how you, so in this case, I had two separate objects that I had loaded into PyMOL, right, to do the morphing. And sometimes you actually don't have separate confirmations. What you have is, well, you don't have separate objects. What you have is a single object that has multiple states, right? And you've seen an example of this before, right? So let's go ahead and delete everything. And remember when we fetched that PDB ID, fetch to line 4, right? We showed that there were 10 states in this particular object. So this single object contains 10 states. And so you can actually use morphing in this case as well, right? So you can go to plugin again and then choose the morphing trajectory, the morphing. And what you can do is to now choose the different states. So let's see. So I can say I'm going to go from state 1 and the end confirmation, right? The same object, but a different state. So let's say I'm going to choose state. Let's say I choose state 5 as my ending state. I can now create a morphing trajectory that takes me from this state, state 1, to state 5. Right? And so once I select this, again, I'm going to click on superimpose and then hit morph. In this case, this is the morphing trajectory. You can see in this example, the RNA itself didn't really undergo a significant, doesn't have to undergo a significant change because the two conformations of the RNA isn't that different. What you do see is that the ligand kind of rotates a little bit, right? And that's probably because there's some symmetry in the ligand, right? And so it's possible that the symmetry was not taken into account appropriately. But this is just not meant to give you a reliable path between these two states, but it's mostly just to demonstrate that if you have a single object in multiple states, you can do morphing between states as well. And so what I showed you here is how you would do that. Now we have this movie, right? And very often you want to litter your presentations with a movie at some point. And so just in the same way we showed that you can export a picture, you can also export a movie. And so let's try to export a movie. And so we're going to go File, and rather than export image, we can export movie. And I'm going to export movie as a PNG, MPEG. This page kind of comes up, so it gives you some information. The encoder would be the tool that actually creates the MPEG movie, depending on whether or not you're using Windows or Mac or what tools are available in your system. You may or may not have access to the correct encoder. But let's go ahead and try to create a movie. We're going to use the MPEG-1 format, and we're going to click Save Movie As. And on my desktop, I'm just going to use Test Movie. So this is a pretty simple movie, not a lot of frames, and so it created a movie pretty quickly. And so let's try to see if we can open up this movie. So here I have my movie, and I could double click on it, and in my case, QuickTime opens up, and I can kind of view this movie. And so this is the kind of movie I could then include in a PowerPoint presentation, or put it on a website, send it on Twitter, whatever. So question in the chat. Yeah, so question about GIF. Right? So let's see. Can you create a GIF? And so let's check it out. So if you go to export movie, what are the options that you have? Quick time. Yeah. So this is something I was thinking about. Oh yeah, you can save it. So okay, let me go back. Let's go to File. Let's go to Export Movie MPEG, and so when you do MPEG, it doesn't allow you to select GIF, right? But I think if you click QuickTime, then you need to actually install this FFmpeg encoder, right? So you have to go ahead and do that. If you do, then it does allow you to get that format as an option, right? So in principle, you can, right? Just for time, I'm not gonna install the encoder, right? But in principle, you can. Actually, another thing I could try. Let me see something else. So let's go File, Save, Export as Movie, MPEG, and maybe you can change. Yeah. So the ability to save as the ability to save as a GIF depends on the encoder you use, right? So if you choose Convert or FFmpeg, you'll be able to create a GIF. And so maybe let's see how long it takes. I'll try to install this and see if it works. So the answer to that question, Pujan, is that yes, you can create a GIF if you wanted to. So I think it's kind of installing something in the background. That's why it's in my it's busy. But the other thing you can also do when working with these is rather than saving a movie, you can save individual PNG files. And why might that be useful? Well, there are times when you might want to edit the PNG files. Let's say you want to add some label to the individual files. So you can actually do that to individual frames and then assemble a movie after the fact. So I do that very often. So let's try to create this GIF. So yes. Okay, so it said it created it. So let's go to my, so I have something here, and I'm gonna open it up in my web browser and see if it worked. Yeah, so you can. Okay. Okay, so what I'll do now is, I mentioned that at the end, what we could do is kind of uh, choose one of these examples and just work our way through in terms of trying to recreate one of these images. Again, well, not again. So there are lots of commands that are going to be used here that we haven't talked about and you might not necessarily understand. And I think that's okay. We're just trying to highlight, you know, some of the capabilities of PyMOL. And so what I suggest you do is to choose one of these gallery images that you want to reproduce, and line by line, rather than just simply copying everything, right, and pasting it into PyMOL, line by line, try to reproduce this. Because if you just copy everything and just paste it in, I think it's not going to give you a sense of how you are, what each line does, right? So a good example might be this one here, right? So what I'll do is say, okay, let me arrange my windows in a way that makes it easy to kind of go between PyMOL. And so I'm gonna delete everything, right? And kind of I try to reproduce this image here as much as possible by following the command. So fetch allows you to get coordinates. So here you have the fetch command and you have the PDB ID. Note that the PDB ID is case insensitive, so whether or not you put in uppercase or lowercase doesn't matter. I'm gonna paste this in here, get my coordinates, and this is what I get. And then there's this command add surface. So this allows you to show the surface. And so let's see what happens. The surface gets shown, right? Now so I should say, what we did is say add surface polymer. And so this poly corresponds to polymer, and the polymer is either a nucleic acid or protein, right? So this command is only going to be applied to the protein, right? So if I said show as surface, everything would be shown as a surface. But by specifying a selection, I was able to actually selectively apply this representation to the polymer, which is the protein. So now I can do something similar for the ligand, which you can, there's a shortcut selection called org for organic. So if I do that, then I show the ligand as stick. It doesn't do anything because the ligand was already shown as stick, right? Then I'm gonna add hydrogens, right, to the solvent. So these are the water molecules around. So I added hydrogens to that solvent. And now I'm gonna color the polymer gray, right? Let's go ahead and do that. So I color the polymer gray. As you can see, we're starting to get closer to this image that they showed us here. Now we're going to orient things based on the ligand. So what we're doing here is changing the camera so that we kind of orient the camera relative to the ligand, which we can the shortcut organic org. So we do that, and you should get this image something like this. And then you can take a PNG. Now you can also kind of change the camera yourself manually if you wanted, right? To be able to get whatever view you wanted. So for example, if I wanted something that kind of look like as close as possible to the image that I'm seeing, right? Something like this, right? So this image kind of looks close to this one here, except for the color of the ligand itself. And now I can create an image, right? So I've been harping on the fact that there are multiple ways to do everything, right? So I can create an image by actually just typing this command png dot and get the png command and specify the name of the file, right? So I'm gonna use the png command and I'm gonna put it on my desktop so that's easy to find. So we can go over here, double click this, you see this image. It's not exactly the same, right? But it's similar. If we wanted it to kind of have a smoother look, we could actually do this, what I mentioned, which is this ray rendering. So if you were to type ray first, you would get this image. And what you can see is, in addition to the representations, you can see these shadows, right? So these really cool shadows show up because you imagine you have a light shining and you can see the shadow of the individual molecules on the surface. And so now once we have this, we can now save the image, and I'm going to call it image ray to just distinguish it. And that shows up, and I could click on this, and you can see it produces a much nicer image that's kind of smooth. So with the remaining time, how about you go ahead and choose one of these images and try to reproduce it as much as possible. I would start with something where you have access to the coordinates, right? So anything that starts where you can fetch the coordinates from the PDB might be a good example to work with. But again, rather than just simply copying and pasting everything, copy and paste individual lines, also pay attention to like the notes in here. So for example, they're telling you exactly what you're doing. So for example, it says set the B factor. I mean, I know you don't know what B factors are for now. We can talk about, I think when Liz talks about spectrocrystallography, I'm pretty sure she'll mention a little bit about B factors. Quickly, that just has to do with the uncertainty in your structure. And so very often you think of the uncertainty in your structure related to the flexibility. And so you can project B factors onto your structure and be able to visualize it. So also you can project other information into this B factor field that allows you to visualize certain properties. But anyhow, go ahead and try to choose one of these cool images and try to reproduce them for the rest of the remaining time. Well, it's just only really 9 minutes, but choose something short and easy. And in the meantime, I'll be here. So if you have questions, if anything, again, this is pretty quick and I appreciate that. I can kind of try to help you with anything that you're kind of stuck on. Next time we meet, what we'll do is actually look at some structural analysis, right? So how can we calculate this, measure distances and angles, dihedrals, and things like that. So rather than creating pretty pictures, we can do more uh, informative types of analyses in PyMOL. So with that, I'll shut up for a bit and then I'll just let you choose one of these and work your way through it.